In this video, I'm going to try to show you some tricks to do NMR questions. Let's have a look at this one. They give you the empirical formula of X, and they give you figure 2, which is an infrared spectrum. They give you a carbon NMR spectrum. Whoops, there we go. I make myself disappear. See you later, maybe. And then they give you this table of NMR data, right? Okay, so let's start from the beginning. Yeah, so the first thing to actually use is the empirical formula. Is C2H4. You see this matches with Cn, H2n. It's not 2n plus 2, 2n. That means that you have a double bond. That could be carbon, double bond, carbon, or it could be carbon, double bond, oxygen. Something to bear in mind. Yeah. All right. So now we have the infrared spectrum. The infrared spectrum, you have a peak which is centered at 3,450, let's say. So 3,450. That would be this peak. So you have an OH from an alcohol. You have the peak at 3000, which is very sharp. That is a CH. Always that. Yeah. And then you have another peak, which is sharp at 1700 more or less. That's going to be the C double bond O. That one. Okay. So we are going to carry on. Carbon NMR. There we go. So they give you a few picks. Another trick, when you start analyzing NMR, always start from the peaks on the left-hand side. It will make your life easier. So this peak is around 2010. So sorry, 210. 210. That would be this aldehyde or ketone. And I'm going to annotate it there. So that's an R bonded to a C double bond O. So yeah, we know we have a C double bond O. That's the double bond that was in our molecule. Cool. At 70 odds, you have a peak, which should be this one, C O. So that means we have now two alcohols. Sorry, two alcohols, two oxygens. Yeah. Remember the molecular formula, the empirical formula was C2H4O. And we can tell now we have two oxygens, so that means it's got to be at least C4H8O2, at least. Maybe more, maybe C12, sorry, C6H12O3. That could be, we'll see, but for the time being, we know we have this. Okay, fine. Next peak at around 24, that could be the carbon, which is next to a C double bond O. That would be the carbon being here. Okay, so that it's a carbon, which is next to a C double bond O. Perfect, and then this one at around 19, I would say. 19, that would be a carbon bonded to a carbon. Fine. Okay, and now the proton NMR. Interesting. So let me do some magic. I'll get rid of this. There we go. Proton NMR data. Okay. So in this one, again, always start from the highest value of ppm. Yeah. So start with this peak, not with that one. And this one I'm going to label it A, B, C, and D. All right, so I'm going to try to bring this down. Nice. So pick A. Pick A, it has an integration value of 1, so probably it's going to be a CH. It is a quarter, so this is your proton A. It's a quarter, so it's next to, actually another trick, always draw this plate formula. It helps. So C, H, that's your proton A. It's a quarter, so it's next to a CH3. It's a 3.9, so 3.9, that's a carbon which is bonded to an oxygen. So this is bonded to an oxygen. And yeah, I think it will be bonded to something else, right? Okay, perfect. So here you could do two reflections. One is that this oxygen, we know we have an alcohol. If this is a carbon bonded to an oxygen, then it's very likely for this to be an OH. But well, let's leave it there in brackets, just as a thought. And the other thing that is really important, you see this carbon is next to a CH3. This CH3 will give you a peak, and that peak, it has to show up somewhere in the table. So is it going to be B, C, or D? Well, it's got to be C or D because they've got area 3, integration 3. Okay, so now we are going to try to identify this guy. So this CH3, could it be peak C? Well, peak C is a singlet, which means it's not next to carbons with hydrogens. So this hydrogen is next to an adjacent carbon that does have a hydrogen. Therefore, it cannot be C. It's got to be D. And actually, D is a doublet. And that works nicely because doublet means that this hydrogen, which has an integration of 3, so it's a CH3, it's got to be next to a CH if it's a doublet. And that's exactly what happens here. So then this peak is peak D, you see, and then you label it. And you keep track of everything. That's looking good. Okay, so that's peak A, with them also peak D. Now we can do peak B. Peak B, integration value 1. So it's only one hydrogen, it's not H2H3. And it is a singlet. When you have something, important trick, integration value 1, splitting pattern singlet, you can be very, very confident it's going to be an OH. Which, well, we knew we had an OH, so that's this one. It could be that one, right? Perfect. So that was quite quick. A OH is always a singlet. Pixie. Pixie, it's integration 3, and it is a singlet. Integration 3 should be CH3. If it has an adjacent carbon, it could have an adjacent oxygen or an adjacent carbon with no hydrogens because it is a singlet. All right. 2.1. 2.1, there it is. It's a hydrogen bonded to a carbon which is next to a C double bond O. And that makes sense because it was a singlet. So, yeah, that's perfect. So that would be your peak C. So, so far we have peak A, B, C, and D. We have 3, 4 hydrogens. That's the same, 4, 5, and 3, 8. So we have 8 hydrogens. So that is C4, H8, O2. Yeah, 4 carbons, 8 hydrogens, great. And now we put it all together. So, what? This is A. I should have put this A here, really. That's your A. That's your D. This is your B. I get rid of the brackets. And then the other fragment, so C, double bond O, C, H3. All right. And that's it. That's pretty much it. I don't know if I can put my image again to say goodbye. Yay, there I am. All right. If you have any questions, I'm happy for you to put them in the comments. Yeah, bye.